So in this video, we'll be continuing doing more questions on improper integrals. So if you haven't watched my last video on that, please, I highly recommend you to check that out before watching this video. So let's start with our questions. It's going to be question 6 now. The integration from 0 to 3 of dx over x minus 1 to the power of 2 over 3. So right away, we can notice that what number or what value of x here makes the fraction undefined. It is going to be x minus 1 is not equal to 0 and x is not equal to 1, since we will have 1 over 0 which is undefined, so we cannot have that. So here we cannot have x is equal to 1. So here what we need to do here is we need to split the integral in two parts. So the first part will be limit b is approaching 1 minus first, so it's going to be from 0 to b, the same integration, so 1 over x minus 1, 2 over 3, and then you plus the other limit now, so it's going to be from 1 plus this time to all the way to 3. So you can see what we are trying to do here. We are trying to go very close to 1 here, both of the limits, but never actually reaching 1 itself. So 1 minus here is like going 0.999 and like endless nines, but never actually 1. And you can see that 1 plus here will be 1.00 and then unlimited zeros and then 1. So it is a very small change, but we never reach 1 itself, because that will make the integration undefined or the fraction undefined. So that's there. And the limit from a is approaching 1 plus, and this will be a to 3 this time, and the same integration, so x minus 1 to the power of 2 over 3. So now we integrate this normally. I'm going to leave the limit for now and add it later. So this is going to be, I'm going to bring x minus 1 to the power of 2 over 3 above, so it's going to become x minus 1 negative 2 over 3, and now we integrate this, so it's going to be negative 2 over 3 plus 1 is going to be 1 over 3, and then you you divide it by 1 over 3 again, so 1 over 3. I just brought the 3 up here, by the way. So that's what we have now, and now we can include the limits, which is 0 and b, and plug them in. So it's going to be 3 into b minus 1 to the power of 1 over 3 minus 3, let me use another brackets over here, and let me move this, actually I need more space. So yeah, brackets, and then 3 into x, so x is 0 here, minus 1 to the power of 1 over 3, and then close brackets. So right away we can simplify this part over here. So negative 0 minus 1 is negative 1, and negative 1 to the power of 1 over 3 is also negative 1, since 1 to the power of anything is 1. So that's there. So this is going to be 3 multiplied by negative 1, which is going to be negative 3, and then there is a negative sign outside, so it is going to become plus 3. So now how do we, I'm going to take the limit here, by the way, we did not include the limit, so limit b is approaching 1 minus here of 3 into b minus 1 to the power of 1 over 3. So here when we substitute b with 1 minus is very close to 1 here, and then we also take the power of 1 over 3, so this number here is going to be very close to 0, let's say 0.00 and unlimited zeros and then 1, and we again make the number more smaller by taking the power of 1 over 3. So this, we can conclude that this number is going to be 0, and 3 multiplied by 0 is also 0. So all that's left here is that we have a 0 plus 3 here. So this is going to be 0 and then plus 3. Now let's actually erase this and put 3 over here. So we are done with the first integration. Now let's move on to the next one. So integration is going to be the same here. I'm just going to change the limits now. It's going to be 3 and a here. So let's write it again. It's going to be 3 into 3 minus 1, 1 over 3 minus brackets 3 into, now you're going to substitute with a. So it's going to be a minus 1 to the power of 1 over 3 close brackets. So now we can simplify this part over here first. So it's going to be 3 into 2 to the power of 1 over 3 minus, now let's take the limit of a is approaching 1 plus. So that is going to give us, actually let me just erase this over here and write it here. And let's take the limit below it. So limit a is approaching 1 plus this time of 3a minus 1 over 3. So here again we are doing 1 plus minus 1, which is very close to 0 again. So hundreds of zeros, unlimited, infinite numbers of zeros, and then there's a 1 here. And again we're taking to the power of 1 over 3, which is even making it more smaller. So we can conclude that this here is going to be 0. So 3 multiplied by 0 is also 0. So it's going to be 3 multiplied by 2 to the power of 1 over 3 minus 0, which is also 0. So here the part, it's just going to be 3 plus 3 into 2 to the power of 1 over 3, and that's it. So here the main thing is that when we have x minus 1, or where is it? It was a minus 1 here. When we have 1 plus or 1 minus, we can directly conclude that this is going to be 0, even though we know that it's 1 plus or 1 minus. The only time we need to be very careful is when we have fractions and we have like number divided by a very small number, then it's infinity, or the other way around. So 3 divided by infinity is going to be 0, very close to 0, not 0 but very close to 0. So that's the only time we need to be careful. But here we had a very easy case. This 1 plus minus 1 or 1 minus minus 1, and that is 0. Let's move on to our next question 7, where we have the integration from negative infinity to negative 2 from 2 over x squared minus 1 dx. So now we realize the first thing is what makes this denominator or this fraction undefined. It is going to be x cannot be equal to plus minus 1. And here we realize that in our limits we are not having plus minus 1. So we don't need to worry about that. Now moving on, let's substitute negative infinity by a. So it's going to be limit of a approaches negative infinity, limit from a to negative 2 over x squared minus 1. Now we need to use what is that called, partial fractions, to be able to decompose this fraction. So here we have, I'm going to do it on the side, 2 over x squared minus 1. The degree of the denominator is 2, so we have two unknowns, and the two factors are x minus 1 and x plus 1, I think. So here is going to be a over x minus 1 plus b over x plus 1. And if you haven't watched my video on partial fractions, you can do that. I have covered very deeply about partial fractions and everything, and I'm just going to do it quickly right now. So it's going to be 2 into a is going to be covering x minus 1, so we are left with x plus 1 plus b into x minus 1. Now you can substitute x as negative 1 and you will get 2 is equal to b into, so minus 1 will be minus 1 minus 1 minus 2, so b here is going to be equal to minus 1, and a here is equal to 1, here is going to be 1. So now we know that our a here is 1 and b here is negative 2, negative 1. So we can erase the other stuff here. Now let's divide this. Let's rewrite the integration again. So we got our coefficients. It's going to be minus 1 over x plus 1 plus 1 over x minus 1 dx. And now let us integrate this now. We can integrate this now, so it's going to be minus ln of absolute value x plus 1 plus ln of x minus 1, and then close brackets from a to negative 2. So now let's substitute our limits. It's going to be equal to minus ln of minus 2 plus 1. I'm just substituting the upper limit and then the lower limit, plus ln of minus 2 plus, oh sorry, it's minus 1, so minus 2 minus 1, close brackets, and then minus, open brackets again, minus ln of a plus 1 plus ln of a minus 1, close brackets. Now do not or we always take the absolute value after simplifying whatever is in the ln. So here it is going to be equal to now minus ln, here is going to be minus 1, and then I'll write it one more time, minus 1, so it's going to be ln 1 plus ln of minus 3, and I'm going to take the absolute value now, so it's going to be 3, close brackets, and then moving on, here is going to be minus ln a plus 1 plus ln a minus 1. So here we can cancel out negative ln 1, since ln 1 is 0, and ln 3 we have it right here. So now let's move on and simplify the minus sign over here and open the brackets up. So we are left over with ln 3, which is a constant, plus ln a plus 1, and then I'm going to distribute the minus sign over here also, so it's going to become minus ln a minus 1, and we can write the limits now. So limit from a is approaching negative infinity. So now if we place a or negative infinity in the first ln a plus 1 here, we will get negative infinity in the brackets, and when we take the absolute value, we'll get ln of positive infinity minus ln of positive infinity again, and we cannot simplify that, that will be undefined, so we don't want that. So here what we're going to do here is somehow we need them in a fraction so that we can use the L'Hopital rule as we used it in our last video, that when we have fractions, let's say a over b, and we have infinity over infinity, we can derive both of the numerator and denominator and then check again for the limits and see the answer. But we cannot do it if we have infinity minus infinity. So somehow we need to change this into a fraction, and the way to do that is to recall the logarithm properties. So ln a minus ln b is equal to ln of a over b. So here we have the same exact case, and here I'm going to take ln 3 outside as it's a constant, so we are left with ln 3, I'm going to take it out, limit, okay, plus limit a is approaching negative infinity, ln a plus 1 over a minus 1. Somehow now we need to get rid of this ln so that we can derive this. Since with the ln we cannot derive this because we don't know how to derive ln here, or we do but it will get more complicated. So what we can do here is we can bring the e here, which cancels out ln, and then use the L'Hopital rule. So let's do that. So let's bring e now. So it's going to be ln 3. I'm going to leave ln now 3 for now and just focus on this part. So it is going to be limit from a is approaching negative infinity, and what was it, e to the power of ln a minus plus 1 over a minus 1, and now e and ln will cancel out. So all we're left with now is the limit a is approaching negative infinity, a plus 1 over a minus 1. Now we can finally use the L'Hopital rule, which we will derive the denominator and the numerator. So the derivative of a plus 1 is 1 over, and the derivative of a minus 1 is also 1. So the final answer would be 1. And now you need to be very careful. Since we introduce a e here to cancel out the ln, we again need to add a ln to balance that e. So the 1 here is actually ln of 1. And the way to think about this is, let's say we have a ln 5, and now to get rid of this ln we introduce a e here, right? So this is now 5, but now since we introduce a e here, we also need a ln again to balance this out, since we cannot just add a e randomly. So here the final answer would be ln 5, since this e cancels out with this, and the original that we had was ln 5, and the ln 5 again is right here, so ln and then 5. So that's the way here, and the 1 here is actually the inner part of the ln, so we need to introduce another ln here behind it, and ln 1 is 0. So the final answer would be just ln 3, which we had from before. So the final answer for this question is ln 3. Let's go up and write the answer. Where is it? Okay, anyways, yeah, it's right here. And as always, I do have a shortcut method for you guys, so let's go to this question and write our. So first of all, you need a calculator which has the integration option, and we had the integration from negative infinity to negative 2. So this method only gives you the final answer, and somehow if you want to recheck your answer, it also works for that. And if this is the MCQ question, then it's your luck and you can get the exact answer. So now when we have negative infinity, we want to slowly increase our limits, or I would say, yeah, the limits slowly to negative infinity. So negative 2 is going to stay the same, and here let's try first negative 999 and then slowly increase it gradually and see what happens to the answer, and everything else stays the same. So x squared minus 1, and now let's try this out. So just do this integration on your calculator. So here we got an answer of 1.0966. So now let's increase the 9s. So let's do 9 and 9, so 5 9s this time, and see what happens to the answer. Now it will take a while for your calculator to calculate it, at least like 1 minute. Now we got 1.09859. Now let's try with 10 9s. So 1 2 3 4 5. So now this is the 1 2 3 4 5. So now we realize that we are converging to a number. We are not going to positive infinity or negative infinity, and here we got the answer of 0.09861, which is ln 3 if you do that on the calculator also. So that's all for this video. I hope you enjoy, and if you have any questions, you can ask them in the comment section. I'll be more than happy to answer. and thanks for watching.